Good morning, everybody. Respected Professor, Vice Chancellor, Dr. Surashimanda, respected Dean, Faculty of Science, Professor Bimal Roy, respected Professor Narayan Banerjee, ISAR, Kolkata, respected Professor Manjusha Majumdar, Department of Pure Mathematics, University of Calcutta, respected Dr. Sudipta Das, respected Head, Department of Mathematics, Professor Ashok Kumar Bhuiya, distinguished delegates, respected guests, scientists, research scholars, respected teachers, my dear students and staff of the Department, University of Bardwan, dear friends and colleagues. It gives me immense pleasure to speak on the inaugural session of the workshop on celebrating the centenary of Einstein's general relativity 100 years with Lambda, organized by the Department of Mathematics, the University of Bardwan. I am indeed happy to be present here before a galaxy of eminent teachers and researchers. I heartily welcome you all in the beautiful campus of our university. First of all, I would like to convey my thanks to the Department of Mathematics for organizing such a workshop to train young researchers in an advanced research topic. This particular workshop concerns a high-grade topic associated with the name of a genius personality of all times. Though I'm not much concerned with the core of the relativity, I do have some fascination, like all other people who nourish science, to this subject that brought about a revolution in the last century with the proposition of such theory. Every rational man is inquisitive about the physical world around us. The Mother Nature is full of mystery, and we, the people nourishing science, always try to unfold the mystery. There are two different entities in this universe, living and non-living. These two are intimately related. The goal of science is to expose Mother Nature and to equalize her. Obviously, living being behaves very differently from the non-living beings. I am engaged in research with living beings, living things. How do the non-living things behave? To me, the first major breakthrough was made in the 17th century AD, and the person was none but the great Sir Isaac Newton. His laws of motion and gravitational law were quite satisfactory to explain the physics of motion. These laws represented the nature in a straightforward way. We even teach these to our school children, but the implications of these laws are very profound, and we use these to explain several phenomena that we encounter in our day-to-day life. Newtonian point of view prevailed without questioning still 19th century AD. To Newton, time was absolute. Even today, it is hard to realize that time can change. But Newton was never puzzled out the source of gravity. This led Einstein to introduce theory of relativity. Special theory of relativity in 1905 and then general theory of relativity 1915. As a matter of fact, a renaissance in the history of science took place in the early part of the 20th century AD. Apart from the theory of relativity, quantum mechanics was also developed for the understanding of phenomena happening in microscopic levels. Behind the development of these two subjects, there was a major issue, the nature of light, that has been lying mysterious since the beginning of the civilized society I see a verse from the Upanishad on the workshop brochure. Hiranmayana patreno satto sapi tam mukham tattam pusanno paprinu satto dharmaya vishtaya. This is verse number 15 of Isha Upanishad. When translated into English, it says, the door of the truth is covered by a golden disc, that is the sun. Open it, O nourisher. Remove it so that I, who have been worshipping the truth, may behold it. Isha Upanishad was composed around the time of Yajurveda, 800 to 500 BC. So you can understand how mysterious the sun was at that time. People of that time were well aware of this. The ancient Greek view of light, popularized by Pythagoras 600 to 500 BC, was that it was a stream of particles emitted by a source. This accounted for the seemingly rectilinear propagation of light. According to this view, there was no need for a medium to carry light. The Greek view prevailed till about the middle of the 16th century AD. The first realization that light moves with a tremendously high speed came when a Romer in the 17th century estimated the speed of light by observing the satellites of Jupiter. His results indicated the speed of light to be about half the presently accepted value of 3 into 10 to the power 8 miles per second. Such a great speed of wave demands propagation medium with extraordinary property, such as it should develop an extremely strong restoring force to enable light to move so fast. The medium was given the name ether. The work of Maxwell showed that visible lights were particular forms of electromagnetic radiation which moved in vacuum with a speed of 3 into 10 to the power 8 miles per second. The experiment of Michelson Morley failed to detect the existence of ether and showed that light in vacuum moved with constant speed independent of the motion of the source emitting it. This ultimately led Einstein to formulate the theory of relativity. The nature of light is still perplexing to us. There are several interesting phenomena which generally do not strike our minds, but very much related to relativity. For existence, we see an object. When light upon incident on it strikes our retina. Suppose we look at the clock and we see it is 12 o'clock. When it happens, if we start running away so that light upon striking on the clock could not catch us, we can never see 12 o'clock. Time will remain standstill to us. I understand the rigorous understanding of the theory of relativity requires sophisticated mathematics. Eminent researchers will give training to the participants. I hope that the participants will be getting enriched from this training program. The knowledge that will be acquired from this workshop will play pivotal roles in their future research. I hope that the workshop will provide a platform for academicians, scientists, research scholars, and the students of the country to participate and discuss about the recent development in mathematical research. Our vision is to build a very interactive and educative program, and we are honored to have all of you as a part of our scientific program. I wish to extend my deepest gratitude to the learned resource persons for taking the pain of coming our Part 1. On behalf of the university, I am grateful to them. Best wishes to all the participants. Have a nice day for the few days at Part 1. I wish a grand success of the workshop. Now I open the workshop for our esteemed speakers to share their valuable experiences and knowledge. Thank you very much for coming and for attention.